Video solutions for Unit 1, two-dimensional geometry homework packet 37 through 60, and it's on reflections and dilations. So let's scroll down here to number 37. We did this one in class. We know that there's certain things in nature that are reflected in mathematics. And we talked about, for example, looking in water. Every class gave the idea of a butterfly. So that was really good. So again, reflection is when one side is the same as the other. Okay, complete the described reflections. Reflection across the x-axis. So according to our notes, first step, we're going to find our axis of reflection. So it's the x-axis. Second step, we're actually going to draw that. So I know my x-axis is right here. Okay? Third step, decide which way our pre-image is going to cross that line of reflection. So in this case, it's got to go this direction. So I know my new image will be up here. Next step, figure out how far away each point is on our pre-image across the x-axis. So in this case, this is already on the x, so it stays. This one is 3 away here, so I go 3 away above. This is 2 away here, so I go 2 above. And then the last step is connecting them. So here we have our image or our post-image. Again, one of the characteristics of a reflection is that it doesn't exactly look like the pre-image, although it is congruent. We know only translations look exactly the same when we're done. Okay, 39, reflection across x equals -1. So according to our notes, we know that x equals -1 is a specific line on a graph, which means it crosses the x-axis at -1. So even though it's x equals, we're going to be going vertically because it crosses the x-axis at -1. And the reason we determined for that is that every point on this line would have the same x-coordinate, and it would be -1. Like this is -1,4, -1,3, -1,2, -1,1. So that's why this is a special equation for a special vertical line. All right, so now we count over 1 on the right. We're going to go over 1 on the left. Over 4 on the right, over 4 on the left. Do not count from this axis. Remember, always count from your line of reflection. That's why I'm making mine big and thick. Okay, over here, 1 to the left, so I have to go 1 to the right. And over here, 3 to the right, so I go 3 to the left. And then we can go ahead and connect them. And when I have a pre-image, all right, that is across the line of reflection, I know that there's going to be an intersection of part of that. So you can see right here where it overlaps. Number 40, reflection across y equals 2. Well, if you used number 39 as an example, we know that this equation then means I'm going to cross the y-axis at -2 or +2. So this time, even though y is vertically, my line of reflection is going to be horizontal because I have to cross the y-axis. And again, if I were to find all these points and find their coordinates, every y-coordinate would be +2. All right, let's go ahead, and this is 2 above, so I go 2 below. Okay, this one is 3 below, so I go 3 above. And this is 1 below, or 1 above, so I go 1 below. Okay, so if I actually get rid of these so they don't get in my way, then our new image is right there. And again, we know that our original image, our pre-image, crossed the line of reflection, so we know our new image has to be overlapping it. 41, reflection across x equals 1. So we know that our line of reflection must cross the x-axis at 1. So that means it's got to be horizontal right there. Okay, we know our pre-image is going to go to the right, so it's going to be over here in this 4th quadrant. S will stay the same. I prime will be 4 away here, so it's 4 away there. G is 4-way, so G prime will be 4-way there, and then we can connect them. Okay? All right, describe the reflection. So what they're asking for is this part right there. They want to know what your line of reflection is. Okay, well, here I have my pre-image, here's my post-image, because we have the prime symbols. I know that each of these images is the same distance from the line of reflection. So I can go ahead and simply try to, well, let's guess. Well, now that image right here is much closer to the line than this. And I can move it, and I can go back and forth until it looks like they're the same distance apart. Or I can simply count the distance between these two, and if I cut that in half, that means I'll have equal distance from the line. So I know that it's 1, 2, 3, 4 apart. That means if I cut that in half, it's 2 apart. That means that my line of reflection must go 2 from this B and 2 from that B prime. And when you look at it, it certainly makes sense. Now I need to name this line or find the equation for it because it's not the x-axis or y-axis. So just like we did over here, I know that this line crosses the y-axis. So it's going to be y equals, and where does it cross the y-axis? -1. So there's my description. Okay, 43. This one we did in class. We won't have this as a test, but I know that my line of reflection is actually diagonal. And we know that every coordinate on this line of reflection has the same x and y coordinate. So it's 1, 1, 2, 2, 3, 3, -3, 3, -6, 6, -9, 9, etc. So if I know it's an equation, the y coordinate equals the x. So that's actually a special equation in algebra for a 45-degree angle there. Okay, 44, let's go ahead, reflect across the x-axis. Right, so I know the x-axis is actually here. Okay, I know that it's actually crossing the line of reflection, so I know I'm going to get an overlapping shape. So here I'm 1 away, so actually y prime will be here. And then I prime is 1 away on the top, so it'll be 1 away on the bottom. C is 3 away on the top, so it has to be 3 away on the bottom. And now when I connect them, you'll notice that I'm actually sharing a couple of the points. And there's my new shape. Okay, 45, reflect across the y equals -2. So I know I'm crossing the y-axis at -2, which is right there. Okay, I count the points above. So B is 1 above, so it's going to be 1 below. G is 1 above, so it's going to be 1 below. That's B. B is 2 above, so it's going to be 2 below. Okay, connect them. Again, I have an overlapping shape. Like that. Okay, 46, reflect across the y-axis. So I know here's the y-axis. So I know it's going to go to the right. This is 1 away on the left, so 1 away on the right. 2 away on the left, so 2 away on the right. This is 4 away on the left, so 4 away on the right. And G is 4 away on the left, so 4 away, 4 away on the right. Connect them, and we have our new post image. Okay? All right. 47, our line of reflection is x equals -2, so it crosses the x-axis at -2. So it's got to be vertical, and it crosses right there. Okay, I don't like that red one. I'll go to my purple. Okie dokie. Here we go. So C is 1 away on the left, so it's got to be 1 away on the right. Q is 2 on the right, so it's got to be 2 on the left. A is 2 away on the left, so it's got to be 2 away on the right. Go ahead and connect your points. And you again have an overlapping image. All right, number 48. Here we have to describe the reflection. So, as we learned earlier, these two shapes have to be equal distance from the line of reflection. If you want, you could draw the shape and try to visually see where they might be the same, somewhere in here. Or we've learned that mathematics will help us do things faster sometimes. So I know I have a procedure for this. I'm going to count from one of my points to its corresponding point, and then since I want the middle of it, I divide by 2. Now be careful, if you count like from C here, remember you've got to get all the way over to C there. Alright? Although, if I reflected, that doesn't make sense. This should have been, this looks like a slide, doesn't it? So I think they just made a mistake on our names of our points. This should have been C prime, and this should have been B prime, because it has to be reflected. So when I count, let's just use one of A. So it's 3 away, then another, oh no, these are halves, so it's right in the middle. So we'll count by halves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's actually 11. So 11 divided by 2 is 5.5. So that means I'm going to be 5.5 away from each of these. So let's just count 1, 2, 3, 4, 5. And then that half would actually bring it to that point right there. Now I can draw my line of reflection. I know that the shapes are going left and right, so my line of reflection has to be vertical. So now I name it. Well, it crosses the y or x-axis at 2, so x equals 2 is my equation. Okay, 49. Here we're reflecting up and down, so I know my line of reflection will have to go this direction, right? So if I simply count from A to A, that's 2 units. If I cut it in half, that's 1 unit. So my line of reflection has to go right through that point, and we already know that it's going this direction. So in this particular case, my line of reflection is actually the x-axis. Okay, dilations. So we talked briefly about this. This is fairly simple. Let me give you an example real quick. If I go ahead and make a coordinate plane, and I draw a shape on this coordinate plane. Okay, so let's make this shape right here. And I want to make that shape twice as big. So the scale is times 2. Well, basically what that means is I'm going to take each of these points and I'm going to extend from the origin. Okay? So I'm going to extend this out this direction. I'm going to extend this out through that point this direction. And I'm going to extend this one out through that direction. So every one of these points has to be stretched out farther away. If I were to actually name these points, that's -2, +3. That's -1, -2. That's -4, -1. If I want to do this mathematically, and my scale says I'm going to enlarge this shape or dilate it by a scale of 2, all I need to do is multiply the coordinates by the scale, and you'll get new coordinates which basically stretch it out. So that means -2 and 3 are both going to be multiplied by 2, and I'm going to get -4 and +6. So this new point is stretched out on this line to -4, +6. And there it is. Look how that works out. Okay, this point right here, -4, 1, would also be multiplied by 2 and 2 again. So I'd get -8 and that was -1. So -8 and -1 times 2 is -2. So if I were to plot that, I go over -8 and it's close. My line's off just a teeny bit right here. Okay? And then finally, the last point is -1, -2. So I'm going to multiply each of these coordinates by the scale factor. So that's -2, and that's -4. So I go over -2 and down 4, right there. So now when I draw my new shape, you can see how it got much larger, twice as big, but it also slid over. So that's what we call as a dilation. Okay, I think some kids think that if I were to go back and take these away, they think the dilation would somehow make it do like this. All right? But we're actually dilating on a coordinate plane and moving it at the same time because it's based on the origin. So now let's go back to our work. So what happens to the coordinates in a dilation with the scale factor of 3? Well, the scale factor of 3 means I'm going to make each of those coordinates, all right? So the coordinates will be 3 times larger because we're going to multiply by 3. Okay, so I'm just going to do a few of these, and then you can do the rest. Okay, so given these coordinates of the pre-image right here and the scale factor right here, find the coordinates. Well, so my new one, r prime, I'm going to take each of these and multiply by a half. So -3 times a half will make it -1.5. And 6 times a half will make it 3. Okay, 52. So w prime, I'm going to take 2, 9 and do a scale factor of 3, which means I'm going to actually multiply by 3. So w prime, 2 will now be 6, and 9 will be 27. Okay, d prime, 4, -2 to a scale factor of 4, so I'm going to multiply both these coordinates by 4. So 4 times 4 is 16, and 4 times -2 is 8. So there's going to be my new point. And finally, q prime, I have 1, -3, and it's a scale factor of 1.5. So 1.5 times bigger. So 1 times 1.5 is still 1.5. Okay, so that's that number. And then -3 times 1.5 is -4.5. So you have to be able to multiply and use your positive and negative numbers. Okay, the last part here, if I'm given the pre-image and the post-image points, and I want to determine the scale factor, here's all I do. Take your post number coordinate and put that over your pre-number coordinate, and then divide. Okay? So 55. I'm going to take my post coordinate, and I just need to use either the x's or the y's. You don't use both. So let's take the x, that's 8, and I put that over the original x, which is 4, and I divide. So that's going to be a scale factor of 2. It's twice as big. Okay, 56. Take your post number, and we'll use the x one again. Take your pre-number, again, make sure you're doing x and x, y and y. The pre-number is -3. Okay, go ahead and divide, and we get a scale factor of 3. 3 times as big. Okay? Number 57, well, if we use our x's, that would be 0. And you can't have a 0 denominator, so we have to use our y's this time. So take your post number of -2.5 over your pre-number of -5. And this time when you divide, you can actually see that it's going to be 1/2. So it actually shrunk, didn't it? Okay, then 58. Take your post number, and we'll do x's again, back to 2. So I'll do that up here. And your pre-number is 8. Well, if we divide, we get 0.25, or I can remember my fraction land work and simplify by 2, and that equals 1/4. So it's 1/4 as big. And finally, this last one, take my, I don't like this decimal here, so I think I'll use this 10. So I take my post number -10, And my pre-number is -4. And if I were to divide that, I'd get 2.5. But I can see that they're both even, so I'm going to simplify. 2 goes in there 5 times. 2 goes in there twice. Now if I divide, I get 2.5 times bigger. And then you can go ahead and do the rest of the work. Good job.